Hi, welcome to you all. I am Dr. Varalakshmi, working as a faculty in the Department of Organic Chemistry, Sri Padmavati Mahila Vishwavidyalayam. Today we will discuss the topics on hydrolysis reaction, factors affecting hydrolysis reaction and mechanism related to it. So the first introduction we see, as we know that substitution is nothing but replacement of one ligand with another ligand, or displacement. We can say simply that those are exchange reactions or displacement reactions. As we learned that while during the substitution reactions, if the reactions occur rapidly, we can say those are labile. Otherwise, if the reactions are occur slowly, those are inert. Hydrolysis reaction. These are the substitution reactions in which ligand is replaced by a water molecule or by hydroxide ion. The reactions in which an aqua complex is formed by the replacement of ligand by water molecule are called as hydrolysis reaction or aquation reaction. See, this is the metal complex which has the ligands A and X. We are doing the aquation of H2O molecule to this metal complex. What happens here means there is the addition of H2O molecule to the metal containing ligand. See here how the H2O attacks to the metal complex means by replacing the X. The reactions in which hydroxy complex is formed by the replacement of ligand by hydroxide ion, simply we can say base hydrolysis. If the attack is means by terms of hydroxide, we can say base. If the attack is in terms of H2O, we can say simply those are acid hydrolysis reactions. Acid hydrolysis. It occurs in the neutral and acidic solution. Acidic solution means its pH is less than 3. The rate is independent on water molecule. So it is first order kinetics. It means that the rate of the reaction depends only on the concentration of the complex only. See the rate, it depends on the rate constant K with respect to initial reactant only, means concentration of the complex only. If the rate of the reaction would be dependent only on the concentration of the complex irrespective of the aquation. Mechanism. How the acid hydrolysis takes place means is by means of dissociative mechanism, that is, or SN1 mechanism. Here the two-step mechanism follows. This is the metal complex having the coordination number 6, means octahedral complex. Initially there is a dissociation of the ligand X from the respective metal complex, which is the rate determining step. Why? Because means this is the step with the slow rate. Resulting complex we got here, it is the complex with the coordination number 5. It means that metal is bonded with only 5 ligands instead of 6 ligands. Another ligand has come out as X. In the second step, the formed 5 coordinated intermediate, it is treated with the ligand Y respective metal complex with the coordination number 6. Here the Y here means acid hydrolysis H2O. This is the diagrammatic representation of the dissociation reaction. Initially, see, this is the complex which is in octahedral structure. It's the metal M. Number of ligands are 5. Another ligand is X. What is the first step means, which is the slow step? Ligand X is replaced from this octahedral complex. Results in the formation of two different types of intermediates. One is with the trigonal bipyramidal intermediate. Another one is square pyramidal intermediate. This is the square pyramidal means see metal is liganded with the square shaped arranged ligands, and one of the ligand is arranged as like that pyramid. So we can say the structure of this respective complex is square pyramidal intermediate. See another intermediate which is arranged such that 3 ligands are at the corners, or we can say equatorial positions in the form of trigonal. Remaining 2 ligands are arranged such that they are the pyramids to the respective trigonal complex. So we can say trigonal bipyramidal intermediate. To this respective two intermediates, if there is attack of Y, results in the formation of the octahedral complex, which contains addition of Y. With the replacing initial stage is replacing X happens, and the final step there is attack of Y to the respective intermediates, formation of the octahedral complex. Here in this acid hydrolysis, the attack of Y is nothing but the H2O molecule. Then what are the factors affecting acid hydrolysis? The first factor is charge on the complex. As we know that as increase in the positive charge on the complex make Ml bond more stronger due to good overlapping between metal and ligand. If there is a increase in the positive charge means there is Ml bond becomes very stronger. It means that bonding between metal and ligand is very good and very stronger one. The decrease in the reaction rate is observed as the charge on the complex increases. As a dissociative nucleophilic substitution, SN1 proceeds seems to be operative. See the first example. This is the complex, cis complex. Here in the first example, the charge on the complex is 1 plus 1. The second complex, this is the charge on the respective metal complex is plus 2. As we said from the above factor, increasing the charge on the complex decreases the rate of the reaction. See, positive charge containing complex, it goes with the faster rate, as well as increasing the charge on the complex, it goes with the slow state. Why? Because means metal and all the ligands makes a good bond with the, stronger bond with the metal. Is the case with the reverse to this one. Second factor. What is the second factor? Means effect of crowding. We can say simply steric hindrance. An increase in the steric crowding around the metal ion, it preferably favors a dissociative nucleophilic substitution, otherwise simply say SN1 mechanism. For example, if we consider this respective complex, means ammonia molecule, here it is there. The complex ion is replaced with the ethylene diamine to this respective same complex, which is having, here you see, if you see the two examples, one example is with the ammonia ligands are 5 in number and along with the chlorine as another ligand. Second example is with the ligands attached to the metal cobalt is ethylene diamine in 2 number, ammonia, chlorine. In between these two reactions, we are doing the acquisition reaction here. What happens means, in the first case, this is the fast rate of the reaction. If we see the second one, it is a slow rate of the reaction. Why? Because means fast rate means there is no any steric ligand here. Simple ligands are placed there. In the second case, if you see En, which is nothing but the steric ligand, ethylene diamine is a bidentate ligand. Since in the first one all the ligands are monodentate, as it is a bidentate, which is the somewhat steric hindrance to the respective metal atom, so the nature of the reaction is slow reaction. The second factor results with the steric hindrance. The next factor, effect of leaving group. The strength of Ml bond is directly proportional to the basicity of the leaving group. The rate of acid hydrolysis decreases with increase in the strength of Mx bond. It means that if there is strength of Mx bond means there is a bond between, as we know that the bond between metal and ligand is there. If that strength is very strong, what happens to the acid hydrolysis means it's very less. Means strength of Mx bond is more, means how there is a dissociation of the ligand takes place. There is no dissociation. So acid hydrolysis is less. With increase in the basicity of the leaving group, it means if the ligand nature of the ligand is very basic in nature, it indicates that a rate determining step in the acid hydrolysis involve the dissociation SN1 mechanism. What is the order with respect to leaving group means carbonate, nitrate, iodide, bromide, chloride and respective fluoride. If we see the nature of the leaving group of the halogens, iodide is more basic, fluorine is less basic. you see the example here with the respective ligands, all ligands are with the cobalt and ammonia. Another ligand in the first case is iodine, second is chlorine, third is thiocyanate, last is nitro. Among these, as it is, iodine is the more basic, so it can be easily replaced, means iodine is easily replaced with the water. In the last case, somewhat it is very slow. Then what are the factors affecting what we learned till now? Means the first factor is charge on the complex increases. What happens to the rate of SN1 reaction? Means decreases. Basicity of the leaving group. If the leaving group nature is very basic, rate of the SN1 decreases. Solvation reaction increases, chelation factor increases, SN1 reaction hydrolysis decreases. Thank you.